Hi, this is Ed Gonfindini. I'm here today to talk about shop class and shop math. When I was a young kid, maybe say 12 years old, I was lucky enough to run into a fellow who was an engineer and a machinist. And I worked for him on weekends, and he kind of mentored me. And his mantra always was, "Do you know your decimal equivalents? Do you know your decimal equivalents?" And math was never my strongest subject. But in any event, I took a lot of drafting courses. I worked in drafting. I also took auxiliary classes in machine shop because they go together. And in my vintage, everything was like go into machines, go into machine shop. There's no money in woodworking. There's no, architecture, whatever. Everything has these cycles. One time teaching is down, then it's up. But in any event, what I'm getting to is my kind of passion was for woodworking, and eventually I got into contracting and woodworking. But what I wanted to do was demonstrate how some of the measuring tools and skills that are involved in precision work get transferred over to woodworking and can really make a difference in your work. So I'm going to demonstrate some basic stuff and then, kind of go on to a little bit of philosophy about how I build my particular type of cabinets. And the big deal here is going to be dados and then how to measure them and get them right. So quickly, what I'm going to do here is try to adjust this, and then you'll be looking at things rather than me, hopefully. Um, and what I originally had gotten into was drafting, and this is just a sample of some of my work, so you can tell that's fairly, involved in precision. And it was fun, but after a while I got tired of wearing a tie and being in an office all day. Well, what I did was I parlayed that with my contracting business. What I do is I provide the customers with a drawing of their kitchen so that they can visualize it. And I'm kind of old school. I'm doing it still on paper rather than CAD systems, but it suits me just fine. And then I have a copy in the shop I work from for building purposes. And these right here are a whole bunch of different tools that various types of tools you can use for measuring, from simple to, high end. This right here, these are what are called parallel blocks, and they've got my name on them, my initials, because I actually made these in junior high. And if you can imagine, I don't think there's too many junior high kids that do this anymore. But the purpose of these was for working on, let's say, a Bridgeport mill. You'd use these as a setup block. They give you they're called 1, 2, 3 blocks. They're 1 inch by 2 inch by 3 inch, but they're very precise because we finished them off on a surface grinder. And they've suited me well, because what they do now today is they serve as a calibration block for what I like to use today for basic work is veneer calipers. And the best thing to do for simplicity is to get the dial type, okay, because they're easier to read, and you get 3 measurements. You get overall, like I said, what I do here is I can take this and go right down to 0, if it's possible to read that. That tells me that this is 0. So then what you do is you lock your dial down to that point. See, it's adjustable. So when you hit 0, you lock that down, and then you're there. And then this can also be, 2 inches. And then when you get it set at, let's say we're going to go to 1 inch, we can lock that knob there. It also can be used for inside measurements. That is equal to that. And then also another benefit is you get a depth indicator on this end, which is very handy for doing things, when you're trying to do depth of cut and various measurements. And you can use it as a setup because you set it where you want it, and then you can use it as a gauge. So it's a very useful tool. Today I doubt they're terribly expensive. These I've had it forever. That's my all-around shop one. And then I've got a nice, neat, clean one that I use that's probably a little bit more accurate, but in any event, those are handy. And When getting down to the situation with, let's go over to wood joints now. Okay. Okay, this is out of a high school textbook that I had, and it talks about the basic wood joints. Okay, and in my purposes of cabinet making, I generally focus on these two here. You've got the dado and you've got the rabbet. I've obviously worked with all of them, but what it is you basically have a group of joints that are universal, and then you've got a lot of different ways on how to make them. So let's take this example here. Now what I've got here, this is a setup master that I've made, and what I've done is I've measured the width of this. Now this is my dado groove. Now the way that you read this in decimal equivalents is, okay, fractions are basically useless, okay? So what you do is you memorize the equivalent of a fraction. So let's say, make it very simple. 3/4 of an inch is 0.750. And you can go to tenths, which is the fourth digit, but really more, if you really don't even need to go to the third one. But the key here is getting down to thousands, you can really make these accurate. And so this measures 0.745, plus or minus, dependent, because see, wood is different than metal. Wood can change slightly with expansion and shrinkage with moisture content. And even on something like plywood, depending on how it's cut and how you measure it. But anyway, for nominal purposes, that's 3/4 of an inch. Now I'm going to show you something. So we got this material here is like a full 3/4 of an inch. This is out of a 1950s home, and this is actually a cabinet door, and it's what they called lumber core. Instead of plies, they actually use solid wood, and then they put a veneer on it. Now this thing here, this is a beautiful, stable piece of material. I saved a lot of this when I took it out. But you can see here, this fit is going to be very snug and very tight. But look at, that's a beautiful fit. See, that tells you that this was a real 3/4 inch piece. Now today, in the infinite wisdom, when I was like, I think in the 70s, they switched over to metric. So now what happens is all your plywoods are manufactured in metrics. And a conversion factor for metric is 25.4 factor. But in essence, what it is all your plywoods are thinner than the nominal American dimension. So this is big box store plywoods, okay? This is the inexpensive stuff that you can get. There's really nothing wrong with it except the fact that you will have some warpage to it, and it is significantly smaller. But if you're building, like, say, shop cabinets, whatever, on a budget, that's not too bad. But look at the difference here. Okay, here's 718. Look at that. 718 thousandths. So that's a lot less than 745. This one here is 6.693. I mean, that's useless. I mean, you can see the gap. Now, if you move up to professional grade plywood, this is a heck of a lot nicer. It's more consistent, a lot less voids. And now even this one though, see, this is 0.715, this is less. But see, now this, even though it's loose, it's not the greatest. Now you go to a pro grade, another one, different manufacturer. This was 0.748. It's real close to 3/4 of an inch. And what's even funny here is the difference, because you got the factory edge here, and this has got kind of a rounded thing. And then you've got the other edge that's in the heart where you cut it. Look at the difference in how this goes together. There's your factory edge. Okay, look at it. Real tight. Now, you normally wouldn't use a factory edge, but then you try to put the cut edge in there, and that's the difference between thousandths, okay? There's the difference. That will not fit. I mean, if I got my mallet, I'll get it to fit, but you know, that's not the way to go. So what I'm trying to get to this, in with this little discussion is this, okay? So let's say, for instance, you want to build some cabinets. My advice to you would be, first of all, pick out the cost level and quality level of plywood that you want to use. And if you're going to do the dados, what you want to do is, once you've established what thickness of the product that you're going to use is, then you can set up your dados, and so that everything fits properly. And the way that you're going to do that is, give me an example here. So this is out of my Freud dado set, and it's a very nice set, and they've got the way that you stack your individual blades to get various thicknesses. And what they do is they have a letter code on each one. So what you do, this tells you how to stack them. So let's say, for instance, we're going to choose 11/16. Now 11/16, you can look on your chart right here, which will tell you is 0.68. So knowing that, what you can do is you come down to the one below it and you get that set of stacks out. So you got that. And then what you can do is you can creep up on it. They give you these discs, okay? These are stamped steel. And what I do is I measure them and then I write down on them what they are in thousandths, okay? So what you can do is you can add up, let's say, for instance, here, we're going to go with 21/32, which is below that. So we add that up, and then we go to 21/32. 0.656. So what you could do there is, if you want to creep up on this and get a fit, you can take, and the beauty of decimals are you can use them on a calculator. You can work with a decimal. You can't work with a fraction without converting it, unless you're going to do it all in your head, and that is just, it's a waste of time. Convert everything to decimals and it's much easier to work with. So let's say, for instance, we're going to do this. We're going to go, you want to end up at 11/16. So you start out with 0.687. That's what that is. Now you subtract 0.656. That gives you 31 thousandths. So now all you got to do is come up with 31 thousandths out of this stack and then add that onto the last one, okay? And you'll get there. And the reason I say that is because if you're in an off thing, and when it comes down to it, it's going to be fit, okay? You can stack these in and it'll say one thing, but it may not actually fit that way. And when you're doing dados, setting them up on your saw, what happens is you end up having to, you shut the saw down, take it all apart, pull the stack apart, rearrange the plates, and that takes a lot of time. So my thinking is this, okay? What I would do is stay with one setup, and then if you got to adjust it by a shim, you can only have to do it once. So that's my thinking on that. And if any of this seems like when you're doing production work, if you get a little bit tired of it and you think, wow, it's a lot of pieces to do in that, this is something that I like to always remember. Repetition is the mother of skill. And if you think about it, these guys here, the Blue Angels, they don't just jump in the plane and fly off and do acrobatics on they don't just wing it, pun. They spend hours planning and strategizing, and they each know what everybody's going to do, and they follow through, and you end up with a safe show. So my thinking is the same thing with this, is that what you want to do is you want to spend your time planning, thinking about what you're doing, measuring, getting it right, and if you get that dado set up properly, you're going to end up with a fit that will go together beautifully with no wiggles, no play, and it's a precision thing. So now when you put your screws in to tie this together, that thing is going to be rock solid, and you know, you're going to have something that's square that you can really be proud of, and you can also end up with just what you're looking for. And the idea of working in millimeters and metrics, I mean, if you'd prefer to do that, you can do that because it's all in a conversion table. But for my purposes, I like to just convert everything to standard decimals, and then everything comes into play and it makes sense. Same thing with dimensioning and callouts. You know, why get involved in all these confusing variations of systems when all you got to do is say, you know, a half inch is 0.50, et cetera, et cetera. And do you know your decimal equivalents? I do, because I got it pounded in my head, and I kept repeating them. It's the same thing with the multiplication tables. You know, I was never good at that stuff, but I just had to repeat it. And in a nice hot summer day in 7th grade, I was stuck there doing flashcards so that I could memorize, you know, what's 7 times 5, so that I would know it. But anyway, I hope this has been helpful, and I'm going to be doing a complete series with a lot of different posts on various aspects of cabinet building and so forth. And I do a lot of other types of things. I love, you know, automobiles and other different types of metalworking and projects. So I'm hoping to be just putting together a bunch of different videos that are just interesting and fun. If this has been like paint drying, then I apologize. But I think it's something that is very useful, and I thank you very much. And as far as my helper over there is concerned, what is he doing? He's just hanging about. He's not doing much of a thing. What do you got to say for yourself today there, guy?
You're a dope.
Yeah, see? He doesn't give a damn about making it right, but I do.